So today I'm going to explain about the equilibrium constant, which is very useful in the design of the reactors like bioreactor, chemical reactor, fermenter. So in order to design the bioprocess equipments, we should know about the kinetics. You need to understand about the kinetics means you need to understand the equilibrium constant, which is related to the forward reaction rate and backward reaction rate. Okay, let's see the forward reaction rate and backward reaction rate here. The ratio between forward reaction rate constant to the backward reaction rate constant when the reaction is attained equilibrium is called equilibrium constant. It can be denoted by K. For example, A plus B that gives rise C plus D. That means uh, forward reaction rate is directly proportional to the reactant concentration. Its forward reaction rate is directly proportional to reaction rate constant. That means if you represent RF is the forward reaction rate, therefore RF is proportional to A into B. Here A, B are the concentration of the reactants. If you remove this proportionality constant, we can get some proportionality coefficient. That is called the forward rate reaction constant. RF is equal K1 into A into B. Okay. Similarly, the backward reaction rate RB can be defined as the product of the concentration, which is related to the products of the concentration of the right hand side of the stoichiometric equations. Therefore, we can get RB is proportional to the product of the concentration of the C and D. This bracket indicates the concentration. Therefore, RB is equal to K2 into C and D. This can be represented as equation 2. Okay. At equilibrium, the forward reaction rate is equal to the backward reaction rate. Therefore, RF is equal to RB. That means K1 A into B is equal to K2 into C into D. So, as per the definition of the equilibrium constant, K is equal to K1 by K2. That means forward reaction rate to the backward reaction rate K1 by K2. That is equal to C into D by A into B in terms of the concentrations. Here C comma D are the concentration of the products. A comma B are the concentration of the reactants. In terms of mole fractions, Yc into Yd by Ya and Yb. That means the equilibrium constant has one more definition, the ratio of the mole fraction of the products to the mole fraction of the reactants. Okay. So we have one more definition from the equilibrium kinetics. The, the relationship between equilibrium constant on the standard Gibbs-free energy can be defined as delta G is equal to minus RT log. Okay. Therefore, K is equal e to the power of minus a delta G by RT. Right? So this is what about the equilibrium constant, which is very useful in the design of the reaction kinetics, particularly for the design of the bioreactor and fermentation process. Okay, let me ask a few questions. So, what is the equilibrium constant? What are the units of the equilibrium constant? So, how to define the Gibbs-free energy and what is the relationship between Gibbs-free energy and equilibrium constant? Okay.